Hi everyone. So I apologize for any confusion with the assignment today. Some of you worked your way through it and figured out what you needed to do either looking at example 6 or by using the traditional method. But some of you guys were getting confused, so I thought it might be better just to say, okay, hold off on that section in case the way we had been solving problems wasn't making sense. I can show you another way. And so that's what I want to do. So let's take a look at a problem like 18x to the fourth minus 21x squared plus 3. That's our original equation. And we're going to do what we call a U substitution. And I mention this process because eventually, someday, if you take calculus, you're going to do something in there called a U substitution, and it's a similar concept. You'll do different operations, but it's the same idea. It's basically taking a piece of the equation and putting in another variable in its place. Usually we use U, and then solving and going back and finishing off the problem. So really, because we're trying to put things in quadratic form, we want to take the two terms that have variables in it, that have powers in a ratio of 2 to 1, we want to get them broken down into the same element that we can then substitute something else in its place, do a simpler problem, and then go back and finish solving. So one thing we could do is we could break down 18x to the fourth and 21x squared into 3x squared. And then we would square it and multiply it by 2, because if we did that, we'd have 18x to the fourth, and 3x squared times 7 would give us the 21x squared. Then we're going to do our U substitution, and we're going to put U in place of 3x squared. So now we have 2u squared minus 7u plus 3 equals 0. Wow, that's not a bad quadratic to factor. You can do the x method if you want, and we'd say, okay, what equals 6? Oops, you can't see that. There we go. What equals 6 and negative 7? And then you would probably hopefully figure out that it would be negative 1 and negative 6. And you would put your the a and the u over, so 2u over both terms, 2u, just like that. Set up your parentheses and solve. And you'd set up your parentheses and you'd end up with 2u minus 1, and, well, if you simplified, because that could simplify to u over negative 3, u minus 3, solve, but now u is a half and u is 3, but we're not done. Now we go back and say, well, u was 3x squared, so we say 3x squared equals a half, and 3x squared equals 3. Solve for x. So this side, divide by 3 or multiply by a third, you get 1/6. Take the square root, but remember, you can't have a radical in the denominator, so you multiply by square root of 6 over square root of 6. So you have x equals plus or minus square root of 6 over 6. Divide by 3, x squared equals 1, square root plus or minus 1, and that's your answer. So that's a U substitution. And I'll do another example in a little bit with that. You can also do a slightly simpler U substitution and simply take the variable and say your u is x squared, and so you'd have 21u and 18u squared. Go ahead and factor. So there's multiple ways to solve. But you can also go back and do this the way we have been doing it with factoring if it works, or you can also use the quadratic formula. So I'm going to show you that example here as well. Let me get the book out of the way. Hang on. Get that out, and let's see here. Get the camera set. There we go. All right, so let me just show you how this would still work. So if you had 18x to the fourth minus 21x squared plus 3 equals 0. Now, I hope a bunch of you are going, I would divide a 3 off. So would I. So we have a simpler problem. 6x to the fourth minus 7x squared plus 1 equals 0. All right, let's factor. Oh, wait, let's not factor. Let's do quadratic formula with that. That's what I want to actually show you. Let's not factor, because we can do that one. But let me show you how the quadratic formula would work with this. Where you say it's x squared equals negative b, so negative of negative 7, plus or minus the square root of negative 7 squared minus 4ac all over 2a. So each time we do this, it's always x squared. Don't forget that. So 7 plus or minus the square root of 49 minus 24 all over 12. Slide that up. X squared. 7 plus or minus square root of 25 over 12. X squared. 7 plus or minus 5 over 12. So now we simplify. X squared equals 7 plus 5 is 12 divided by 12 is 1. And x squared equals 7 minus 5, which is 2 over 12. 2 over 12 reduces to 1 over 6. So you have x squared equals 1 and x squared equals 1/6. So we got to finish that. Square root. Remember when you're square rooting a variable and you're doing that root, you need to say plus or minus 1. And we square root over here. And we say x is equal to plus or minus 1 over the square root of 6, which I've already said you can't have that. So we rationalize the denominator. Just multiply by whatever the root is. That the roots cancel. And you are left with plus or minus square root of 6 over 6. And there are your two answers. So same thing. There are multiple ways to solve these problems. If you like that use substitution idea, it's not a bad one, and it works for some people. However, if you're more comfortable with attempting just to factor and to use a quadratic formula to help you solve, that is perfectly fine as well. I'd like to do maybe one more example as a use substitution, just so you see how it works, and then I'll let you work from there. Okay. Like I said, ultimately your choice in how you want to solve. Let's try number, let's see here. Let's actually do 44. 4x to the 4th minus 14x squared plus 12 equals 0. Okay, so we need to figure out what could we write kind of as a power thing happening here. Something squared. Well, we could do 2x squared. If we do 2x squared, that would give us 4x squared. Minus, can we turn this into 2x squared? Well, yeah, 7 times 2x squared plus 12 equals 0. So if we do that, that means our u substitution is u is going to equal 2x squared, and we'll deal with that at the end. So we'll have u squared minus 7u plus 12 equals 0. Notice when we do the u substitution, we don't divide anything off right away, because if we had done that, we would have had a problem where we couldn't have done a u substitution. So this is good if you're not thinking about dividing something off. Maybe try the u substitution. All right, let's factor. This becomes one that we can pretty easily factor. We got 12 up there, a times c, and b is negative 7. Ask yourself the question, what adds up to negative 7 and multiplies to 12? How about negative 3 and negative 4? Put u over it. U minus 3 times u minus 4 equals 0. U minus 3 equals 0. U minus 4 equals 0. U equals 3. U equals 4. Now we're not done. We said u is equal to 2x squared, so we now have to go back and say 2x squared equals 3 and 2x squared equals 4. Solve for x. Divide both sides by 2. X squared equals 3 halves. Take the square root. X is equal to plus or minus square root of 3 over square root of 2. Rationalize your denominator. And x equals plus or minus square root of 6 over 2. Well, that's kind of yucky looking, but that's the answer. This side's not so bad. Divide by 2, divide by 2. X squared equals 2, square root, x equals plus or minus square root of 2. So, not terrible. Not terrible at all. So that's just a way to do, another way to solve these kind of problems. You can use substitution if you want. You can just use your factoring and quadratic formula stuff. Whatever makes you feel the most comfortable as you're solving. All right, thank you.